What's going on YouTube? This is Ipsec. I'm doing Sync from HackTheBox, which is probably one of my favorite boxes in a long time because it taught me a lot of things that was on my to-do list, but I just never found the time to learn about them. The first off is doing an HTTP smuggling attack. I knew kind of about it, but never understood the implications. In this, we'll use the HTTP smuggling in order to steal another person's cookie, kind of like a cross-site scripting attack, but with no JavaScript whatsoever. Just a fun attack amongst the protocol itself. Then once we get a shell on the box, we enumerate a bunch of AWS secrets things, querying the secret manager to pull some passwords, and then querying the KMS to decrypt a file. And then once we get root, I'm going to talk about what me and OXDF did to make this box stable. I learned a lot about like kernel modules, which I don't show in this video. That's in the UHC September qualifiers. In this video, we talk about using iptables rules to create a IP modulo router, which I think is pretty cool. But with that being said, let's jump in. As always, I'm going to start with the nmap, so -sc for default scripts, sv enumerate versions, oa output all formats, put in the nmap directory and call it sync, and then the IP address, which is 10.10.10.225. This can take some time to run, so I've already ran it. Looking at the results, we have a lot of information here, so let's just start off from the top. First thing is SSH on port 22, and its banner tells us it's an Ubuntu server. If we look at the specific version for Ubuntu 0.1, this is unique to Ubuntu Bionic, which is, I believe, 18. So if you just Google this string or go to Launchpad and search it, you'll find out that this is Ubuntu 18. Not much you can do with that information, other than if you tried to mimic this server for any reason, like doing a binary exploitation down the line, that's the distro you'd want to pull. The next thing we have is port 3000. Nmap doesn't exactly know what 3000 is by default. It thinks it's PPP, which I think is point-to-point protocol, but it runs this fingerprint settings script, which essentially just connects to the socket and dumps a bunch of information. So it's sending a 400 bad request, so we know this is an HTTP server, and the reason why it sends it is because it kind of just connects the socket and sends it gibberish, which isn't a valid HTTP request. We can try to mimic it, like 10.10.10.225, port 3000. If I just say, like, please subscribe, and hit enter, we get that 400 request. If we sent a normal HTTP request, like get/HTTP, is it /1.1, like that? Required host header, but it's getting us more information, so we could follow on and say get/HTTP 1.1 host ipsec, and we get a page. So because nmap isn't sending a valid HTTP request, that's why it sends this 400. If it does send a GET request, we're getting this 200, and it looks like a page back. If we look at the title, it's get tea, get with a cup of tea. We got a CSRF token, a cookie that says I like get tea, so this is definitely an application called get tea. Going to the next port, we have 5000. This is HTTP, and nmap is telling us this is gunicorn version 20.0.0. Just like before with Ubuntu, I always like looking at exactly what this version tag is. So I'm going to go over to Google and just search gunicorn changelog. And we got to put a space there. Let's see. Go to Google. Go to the changelog. And we can see 20.1.0 is released 2021 February 12th. But we're on 20.0.0. So I'm going to go to the changelog 2020, and we see there isn't really any versions here. It just says one unreleased. So let's go changelog 2019, and we can see 2004 was released 2019 November 26. November 23rd is 2001. There was like, man, it was active right here. That's like 3 minor versions in a week. Version 19 was released November 23rd. We can keep going down. We see 20.0 comes out October 30th. So October 30th is our version. Then the next release, we can look at the results, and they fixed chunk encoding support to prevent any request smuggling. So this piece could be key later on, but I'm just going to continue with my enumeration, trying to remember about request smuggling if I run into issues. So let's go to get tea, which is 10.10.10.225, and we have this page. I'm going to do Control U to see if it has any like version indicator of this, and I can't see anything. We have Go 1.14.12, so we can also go to Google and search for this and see if we find when this is. June 10th. Where is it? Google said June 10th, but this says September 9th, 2021, which doesn't look right because that is like a day ago, right? Like, this box is retired. It should be much older. Let's see. Let's go to this page. We get this. Okay, this looks better. November 12th, 2020 is probably around the time this Go version released. So you should be taking like notes of just all the versions and the dates to build kind of a story around the box. That gunicorn being 2 years old is the thing that sticks out the most so far. We can try to enumerate Git's version. So generally what I do is go Git GitHub, see if it's open source. Looks like it is. And it is a Golang application hinted by the repository beginning with go dash. And then looking at these files, is there a Go? Yeah, golang.yaml. So I don't know exactly how to enumerate Golang apps or how like they generally work under the hood. I'm just going to check if this changelog.md exists because it is 13 days ago. And looking at it, looks like we have a bunch of versions. So I'm going to try going to /changelog.md. We get a 404. They have this web source directory. So this is probably where I'm going to start. Web source /js. So let's try this /js. We don't have anything, but if I do F12, refresh the page, let's see. We have some JavaScript files, so jquery. And jquery is within this JS directory. So we can do js/jquery. Do I have a space or something? I have a space in the folder name. And we get this page. If we just do js/, we get a 404. If we put a file afterwards that doesn't exist, we get this still 404 page, but less data. So we have a way to enumerate if folders exist on the server by just making it access a file. And oh man, we got a version right here, Git version. Awesome. We don't have to go into any more because we know it's 1.12.6. That is good. So let's go over to here, Git. And I have not prepped any of this like enumeration stuff. So this is all going kind of live. So I was actually surprised to see it there. Go to changelog. We can look at 1.12.6. Man, is not even on this? 1.14, 1.12.3, 5. There's a lot of data here. So 1.13 is 2020. So 1.13.1. So I can search that. 1.12. 6 doesn't exist on this changelog. But it's here. Weird. But we know it's probably sometime after October in 2020. So still the oldest thing right now is HA proxy. And keep in mind that these boxes are generally like 6 months old by the time they retire. So Git probably upon release was near the latest version. The other thing I do if that did not work, I would go and download this jQuery file. So let's go jquery.js. We can go here, make dir temp, so we don't clog this up. wget jquery md5 summit. And we could Google the md5 sum, probably get nothing because it just doesn't work that way. So nothing here. But if we go to VirusTotal, this is one of my favorite ways to identify like when a file is released. Just go over to the search tab, put that md5 sum in VirusTotal, and we can see It was probably last seen 7 months ago, but if we go over to this details tab, we can see the first emission, October 24th, which kind of relates to the Gitea version now, because we know Gitea was 2020 October 10th, October, sometime after that, and it was first submitted here. So it's probably that version, like around that date. So I'm saying a lot of words. Let me go back. Enumerating the date of Gitea via jQuery is probably correct because based upon the changelog, we know it was released in the same month that VirusTotal's first seeing this jQuery file. So that's actually pretty cool. Didn't know that when I was first walking through this box. But that's enough looking at Gitea. I'm going to look at the next thing, which is port 5000. And this is where that outdated version of gunicorn was running. So if I try to sign in, let's try admin password. We don't get anything. We just get invalid credentials, but we can sign up. So I'm going to try signing up. The username I'm going to do is just ipsec. Email is going to be root@ipsec.rocks. And I'll try a password of password. I'm going to just start turning Burpsuite on, so I'm logging the request, and I can go back and look at them. Burpsuite is not intercepting, but this way when I click sign up, and if I get stuck, I can just go to HTTP history and kind of look at the request. And then we could try things like changing IPSEC to put cross-site scripting in here. So if I did bold IPSEC / bold, we could try seeing if this works. There is cross-site request forgery, so we probably will just get a CSRF error if we do that. But I don't see where it's saying my name here too much. We got email up here, but things I would try if I run into a big wall. Not focusing on it too much, we can leave comments. So I'm going to do the same thing, see if it processes HTML. If it does process the HTML and this comment is bold, I would try putting a cross-site scripting thing in to see if anyone's checking this page and potentially steal their cookies. Don't have anything there. If we go to this notes page, we can enter a note. Same thing, bold test/b. Just one of the payloads I generally do. We can click view, and we still see those tags. Again, I'm looking to see if test was bolded. Other thing you could do is 7 times 7 in these curly braces to see if it's server-side SSTI, server-side template injection. Click this. We don't see 7 7s or 49, so not SSTI. We can delete our note, so if I click delete, we have this. The other thing we could try is a IDOR thing, trying to access a note we don't have access to. So we could try fuzzing note 1. Was it a post? What was that? 35913. Is that what I tried to get here? That's probably the deleted note. So we can try notes 2. Just get redirected here. If I copy this, let's try something real quick. Let's do note 9001 because I don't think that note exists, and we still get an internal server error. So we kind of have an IDOR vulnerability, I think. We can't actually get the information, but we can confirm a note exists potentially, because if we try a low number note, which we assume is going sequential, it just sends us a redirect. So chances are the application is saying, if this note exists, check if I have permission. If I don't have permission, redirect me. But if the note doesn't exist, then it's hitting some type of error in the web application. So that's just interesting to note. We can validate that notes exist. Going over to the contact does nothing. So looking back at this tab, we can see this via tag, and it says via HA proxy. An HA proxy is just something that sits in front of gunicorn. It stands for like high availability proxy. So this IP address is checking multiple web servers. If one web server goes down, it would send it to the next one. But it's interesting why both of these things exist on the server, especially a gunicorn version that we previously discovered is 2 years old. So I'm going to do is just Google for like gunicorn HA proxy and see what we get. To do that, I want to turn Burpsuite off. So gunicorn HA proxy, go to Google, and let's see. Add exploit in the tag. It's funny that Google's like, oh, you want to add exploit into this. And looks like we have a DEFCON CTF based upon this specific version. So we could read this post. It's talking about doing some type of chunking, adding a vertical tag on this transfer encoding chunked header, and also sending a content length header. This isn't the post this isn't the post I used to understand the vulnerability. It is over here. So if you're confused, I would recommend reading both of these because all my understanding of HTTP smuggling is based off this machine. I had not done it before, so I may be wrong when I'm trying to explain things. But essentially, this works because, let's go over to Burpsuite real quick. Let's turn it on, send this request. It works because when we interact with this service, it is sending the request to HA proxy, which then sends it over to gunicorn. Because the TCP handshake for each packet's actually quite a bit of overhead, there's this thing called chunking, which allows you to do multiple HTTP requests in one single packet. Now, they use the vertical tab when they do the chunking request because HA proxy is going to ignore it. And then when it makes its way over to gunicorn doesn't ignore the vertical tab and treats it as a chunk thing, letting you to hijack the request. So I'm going to delete some of this header so we don't really go off this. Or by off this, I mean like way too far down. Let's see, let's move this connection closed. DNT, I forget what that is. We don't need all this except, I think this is all we need. Yep, the HTTP request works. So what I'm going to do is add the transfer-encoding, and we're going to say chunked. And we also have to add the vertical tag, vertical tab, TAB. And it's a bit of a pain to add it into Burpsuite. The best way I've done it is if we just do non-ascii, we can see the vertical tab is hex 0b. So we can do printf and then \x 0b, and it's going to show nothing. But if I xxd it, it comes out to 0b. If we do like 41, it comes out to capital A because 41 is hex for capital A. So we're going to do 0b, then Base64 encode it, and we get this CW equals. I'm going to copy that. I'm going to put it here, and then highlight, convert selection, Base64 decode, and it magically disappears. But if I highlight the section, I can see selected text has this box because it can't display that character and says it is chunked. The other thing we need, which I'm surprised I don't see it, maybe I accidentally deleted it, is the content length tag. I'm going to remove this, send. Let's see. Okay, there we go. Burpsuite will automatically add this content length, and it's a bit annoying sometimes, at least when doing HTTP smuggling, because it's going to auto-populate the content length with whatever is in the HTTP body. If you want to remove that feature, you can just go to this repeater and update length and take that off, so it will no longer automatically populate that. But we can leave that enabled for now. And the reason why we need this is because we added this vertical tab, HA proxy is going to ignore this encoding, and it's going to obey the content length. So we want to add a second request, and before we do that, we add this 0. And that's because of how chunking works. If you look at like the RFC for this, it's kind of like a serialized format. So the whole idea of this is to be able to send multiple data or multiple things in one packet on different TCP connections. So we could say like for, and then message equals, and then, or we did the for because message equals is 4 characters. And then the next thing we could say 3, and then, or we can say 4 again, then test. So we send the length, we send how much we want, then we send the length, how much we want. If it was only 1 character, we would do 1A. And then when it sees 0, this is when it terminates that HTTP request. So because we don't actually need anything in this body, I can just leave it at 0, and then we can go start crafting the next one. So I'm going to do a, let's log in again real quick before we go on. So turn off, I can do root at ipsec, log in with password. What? Root at ipsec.rocks, password, log in. Probably had a typo. We can either do this with a comment or we can do it on a note. Since I want to kind of keep this private, I'm probably going to favor towards doing it on a note because anyone can see the comments page. So if I was trying to do an attack with smuggling, I wouldn't want anyone to be able to see it. I only want that information. So I'm going to do it on this note page. So let's intercept this request so we can see what the packet looks like. Intercept is on. Go to Burpsuite, save it. And it's doing a post to /notes using my cookie. We probably don't need the get t stuff. We just need session. So let's go and send this over to repeater. I'm going to send this to be model, I guess. This will be smuggle. So on model, we need to send post. We need the host header set. We probably need our cookies. Repeater, smuggle, cookies, and then we need content length. And then we also need the body, which is note is equal to. And we leave this blank. So the idea here is we are going to start a GET request, and HA proxy is going to send this whole thing. And then if someone else makes a request, they're just going to append data to a note. And then when it sends it to gunicorn, gunicorn is going to go, oh, this is a chunked request. Here is the very first GET request. And here's the second one. And this is the data of the next person to hit the page. And for this, we'll have to know kind of like the content length, because this is where like Burpsuite probably limits a lot of people's understanding because it automatically always populates this. But let's turn this off, refresh the page, and just go like that. I'm going to go back to Burpsuite. I'm going to say, please subscribe, right? And we send this, go to repeater. We can see the content length is 21 because this, if we do echo-n, wc-c, is 21 characters. So if I just send this request, it'll say we are redirected. I can go off of Burpsuite, and when I view this note, we see it says please subscribe. Now, if this content length was different, subscribe looks like it is 4. Is that 4? Let's just remove 10 characters from this. So content length is now 11. Again, I'm not taking the note or changing the note in any way. And we go back to notes. Go view. Oh, that. Oh, crap. So remember, I changed it. And we're back here. We have to go to repeater tab. Take that stupid update content length automatically off. Go here and view the latest note. It only says please now because when gunicorn processed it, it said, oh, the content length is 11. Okay, that's 11 characters. I'm going to stop processing after this and drop it. So that's why for this content length, we actually kind of want to get an idea how big the header is. So I'm just going to copy this. We can v test.text, paste this, wc-c on test.text, 155. But if I grab like a normal request, let's see what this is real quick. V test.text, wc-c. This is 580. We can try 580 to see what happens. So let's go back to smuggle. 580. And then this content length is going to be the length of this. And we can just leave it at auto generate because that's fine. If I grabbed this, did v test.text, deleted this, replace it here, wc-c, 173, because I have a line break at the end of this probably that is counting. But that's where the content length is there. So let's go and see if we trigger this ever. So I'm going to delete all these comments or links. And we're going to send the request a few times. Notice this time it is hanging. I'm not sure why it's hanging for so long this time. Probably because this content length is too big and the person that we smuggled against adding it didn't send enough data for this content length to finish, so it's kind of just hung that request. If I refresh this page, we don't have anything. So what I want to do is shrink this content request. Let's just say 280. Send this a few times again. This time it looks like it redirected. And if I view this note, we can see, is this myself? This one, maybe my own cookie. Whoops, did not mean to do that. We can just see what this ends in. EY, that looks same. This looks like potentially my cookie. So because I refreshed like too quickly, I HTTP smuggled on myself. And that's not the goal. So let's go back to notes to see if we have anything else. We have a few more keys for me hitting that. This is note/delete. I've never queried delete, and we have a different cookie. So this one looks good. We can do F12, go into storage, change out the session for the new session. And when I refresh, I am now admin at sync.htb, and we have access to IDs 1, 2, and 3. So before we go digging into this, I want to make this a little bit more reliable. So the reason why we had to keep sending this request is because HAProxy was deciding, I have enough data, I'm just going to send it over to gunicorn now. And if someone didn't come in right after us, then it just sends our request. If someone comes in right after us, it's going to send our request and theirs. And we can kind of always win this race condition by just keeping the socket open longer. Because Burpsuite Repeater doesn't really support the keep alive connection by doing chunking, whenever I send this, it immediately closes the socket. I don't know of a way to keep the socket open, but if the socket stayed open longer, then it would take longer for HAProxy to send the data over to gunicorn. And because it takes longer to send the data, there's a higher chance that someone comes in right after us. So what I'm going to do is let's just copy this entire thing to Base64. So let's do, let's see, convert selection, Base64, encode. We can copy this, make dir smuggle And V, we'll just call this payload.b64. Paste this. And then I guess we can go into Python real quick. So V exploit.py. And the tricky thing about this exploit, we're actually not going to use the Python request module, even though we are sending an HTTP request. And that's the same reason as Burpsuite. It'll just close the socket for us. Instead, I just want to jam data on a network pipe and keep it open. And I would use netcat. Actually, maybe I'll use netcat if I xclip this. The reason why I wasn't using netcat is because of the, let's do cat payload base64-d to payload. But when I copy and paste this, I don't know if copy and paste handles this vertical tab well. I could probably just xclip it actually. Selection dash clipboard. Let's see. Xclip. Let's see. Selection. How do we xclip? Xclip dash help. Xclip dash h. Let's see. Oh, dash selection. Dash selection. Clipboard. I'm also going to do primary. Make sure it's on my clipboard. That looks weird, but let's try it, see if it works. Netcat 10.10.10.225, port 5000. And, ooh, I actually probably want to log out because we no longer see our notes. There we go. So see what happens if I just jam data like this. And then Control C. Do we get someone else? Yeah, it doesn't work that well. I'm guessing just how we're sending the data. So let's go back to exploit.py. And we want to import socket, import time because we need to add a sleep. And I think that's all we need. So with socket.socket, we want to do TCP. So this is essentially like mimicking netcat. The first thing we want to do is connect. And we send it a tuple, so we do that to parentheses, 10.10.10.225, and port 5000. And for host, it wants a string. For port, it wants an int, which that is fine. And then s.send request. We don't have that defined yet. Time.sleep. Let's say 5 seconds. Okay. And then we can say request is equal to open payload dot read lines. Ooh, there's multiple lines here. I'm going to do payload.b64 0. And then we can say import base64. And then request is equal to base64.b64 decode request. And then before sending it to the server, I actually just want to send it to myself. So let's say 127.0.0.1 to make sure everything looks as expected. So Python 3 exploit.py, nc lvnp 5000. So we get a connection, get slash, this looks normal. And I'm guessing what happened before when I did the netcat, me hitting enter, I did a line break here and it ended that request or something. We don't want that. And netcat didn't send anything until I did hit enter. So it's like chicken before the egg situation. So that's why I'm resorting to Python to do this. So we can edit this, swap this out to send it here. If I refresh this page, we only have the 3. run it. It's going to sleep for 5 seconds, but I should always win the race condition because HA proxy is no longer going to send the request within the 5 seconds. Refresh the page, boom, new note, and we get the session. Notice this X forward, it's kind of chunked here, and the reason why is because the content length. So actually we can just cat this real quick. Echo-n. Let's put this in single quotes. WC-C, that's 269. And then if we look at the actual request, Control-Shift-B to unbase64, let's see, 269 is there. The note is 5. So there's something slightly off. I'm guessing like these spaces are actually more than one character. So it's probably \r/n, and it's just showing it as a space. But that's probably the issue why it's a bit different, because 269 plus the 5 here, which would be 274. And there's probably 6 lines here, and it's just counting the lines incorrectly. If you really wanted to, we could try upping this. So let's say 290. Let's send it a few times. I think that time maybe we hit the thing. So let's see. That was the last one. Let's check these two. Do any of these have notes delete? Yep. So now we have more. So that's X forwarded 4. 1010. And if we increase that a little bit more, let's say 330. 1, 2, 3. Let's see if we got any. Yeah. Doesn't look like we had any hits. We should convert this over to the Python script, but I was just being lazy. If we don't have anything, I'll convert that to Python and see. There we go. We have the full X forwarded 4, I think. Nope, that is my request. Let's just convert this to Base64. Control B, copy, V, payload.b64. Python 3, exploit. It's going to wait the 5 seconds. Okay, that's done. Refresh this page. Oh, we don't have anything. So maybe the content length is too long at this point. I'm going to run it one last time. And then if it's too long, I'm going to shrink that content length down. So we're not getting anything. Control-Shift-B. Content length, let's say, instead of 330, 305. Let's try that. B, payload.b64. Wait a few seconds. Okay. I'm not sure what I broke. 290. And if this doesn't work, I'm probably moving on. Hopefully, I explained it well enough. Let's see, cat payloads B64, Base64-D. 290, okay. Come on. I wonder if that X forwarded 4 is the last piece. There we go. I'm not getting the IP, but I'm sure if I increase that slightly, we'd see. But, yeah. Let's just take this cookie and move on. So go to storage, paste. Actually, let's see, dev, chef. Did not get them all. Let's see, refresh. I am admin. And oddly enough, I wonder, let's see, do I have view? Let's copy this link, or we can just click the link now. And even admin can't view a low priv user's notes. That was just an interesting thing. I knew admin couldn't like list their notes, but I assumed if he knew the ID, he'd be able to hit it, but guess not. So we have 3 different credentials. Nagios admin, we have like nagios.sync.htb. So what I would generally do is v etc hosts and add each of those hosts. So we can do nagios.sync.htb, go over here, code.sync.htb. Whoops. Oh, that copied a bunch of junk. There we go. And then the last one would be chef. And then I would hit each of these on port 3000 and 5000 to see if I go to a different page. None of them actually bring you to a different page, so I'm going to ignore that and not waste your time. Nagios is like Zabbix, if you know Zabbix. If you don't know, it's just a monitoring application. It just runs a script every X minutes or seconds and tells you if a service is up and down. It may ping a host and things like that. So it's an infrastructure monitoring application. Code, I don't know what code is. Chef, we just went over Chef and Knife. It's like a DevOps tool. Code, maybe like VS Code or something like that, but I don't know exactly what that is. But the idea is you're trying the username and password in each of these. So dev node, if we do code and try logging into each service, we don't need to log into this one because we're already admin. We could potentially want to see the notes of other users since admin can't view the notes, but sake of time, I'm going to log in here. This was root, I think was the username and the password, and log in. Again, that one was here, this dev node. So it's password reuse. Let's clean up our tabs. And now that we are in this, we can see a few Git repos. Oddly enough, it says 4 repositories, but 3 are listed. If I go to Explore, we have 1 archived repository. So let's go to Elasticsearch. This one looks interesting. It's Elasticsearch, which I think is port like 9200 and then Kibana's 5601. Both those ports weren't listening, so I'm kind of ignoring this because I don't see Elasticsearch running. We have this serverless plugin, and looking through this, let's see, package.json, what is it using? Saying it's running LocalStack. LocalStack's default port is 4566, so we can't access it. If you know from, I think Bucket was the other machine that used LocalStack so far, it emulates like AWS. We have no way to access this, so kind of put down the back burner. Serverless is like Amazon's keyword for Lambda, or maybe Lambda is the keyword for serverless, but there's probably some type of Lambda thing. If we look at example service, serverless.yaml, we can see it's like a hello world application potentially, but we can kind of ignore that. We have this key management that is archived. So looking at this, key management, EC2 instance check and key rotation. And then the final thing is log management. And looking through this, it looks like it is CloudWatch. Again, we don't have any way to hit 4566, so I'm going to ignore it. We have some access keys though, and they're commented out. I'm going to look at the history to see if it was ever committed for that. So looking at this, we can see we do have their AWS secrets and default region here and a git commit. So this is definitely interesting. We have chef events as well as a log name. But what I want to do is go to key management and looking at where like a config may be, maybe keys.php. And this is talking about KMS for documentation. Don't really see anything. I'm looking for like a config. Does config exist? No. EC2. It's doing a save key location here to save a private key. If I do history here, we can see it's adding an EC2 key, and this is just a SSH key. We can view the file, copy and paste this. So, whoops, save, v, I think Marcus was the name. Paste that key, ssh-i, marcus.pem, marcus at 10.10.10.225. And unprotected key file, let's do chmod 600. And that is wrong. Was Marcus the name of this? Let's see, we began key. And it's telling us it's an invalid format, which is definitely annoying. Let's see, vmarcus.pem. Does it want a line break at the end of this? Huh. But the other way, if you didn't want to look at individual files, you could just look at commits. And if you look at the commit for adding EC2 key management, you can see it here. So there's something weird about this. I'm just going to do raw. And I wonder if I can just wget this file. File not found because we need the cookie. I'm just going to do file save page as. And we can do HTTP sync and call this, I'm just going to call it Marcus. I'm not going to do the PPK. V marcus.pem. Oh, it's in Smuggle. Cat Marcus. Okay. chmod 600. Let's try ssh-i Marcus. And see if we log in. We do. So what is different between these two keys? Diff Marcus and smuggle marcus.pem. What? Cat Marcus. Smuggle marcus.pem. These look very similar, but smuggle. Oh, it probably just have to trim those beginning spaces. I did not notice I had those when I pasted it in. Let's see. I could have probably just done like s:4 G, like that. Wait, %s 1 2 3 4 5. Let's just clear that. There we go. So now if I ssh-i smuggle marcus.pem, Marcus at 10.10.10.225, all is right in the world. So that works. So whenever you see that error about SSH keys, be sure to take a look at it in depth. But now we are Marcus on this sync box. Going back to the Gitea, we had Elasticsearch, Lambda, key management, and log management functions. So I'm going to check if Elastic is running. So I'm just going to do ss-lntp to look at listening ports. And these 6000s, I'm going to guess is going to be like Docker. The main thing I'm looking for is port 9200 or 5601, which is Elasticsearch and Kibana. I don't see those, so I'm pretty much just going to ignore this Elasticsearch thing. The next thing is Lambda, and we can check if we have like AWS tools installed. We have AWS and AWS Local. I'm going to use AWS Local because this is a local stack one that's designed to work with it. If we just use AWS, we need to like -- endpoint URL and also specify a secret key. But if we just do AWS Local, we don't have to worry about any of that. So AWS Local, and they can do help to get like the man page for it. And we can look at all the services we have. So this can be the second argument. We have tons and tons, but one of them is Lambda. So I'm going to do AWS local lambda help. And we can look at things. I'm going to look for something that's relatively basic that anyone could do, like list-functions. So AWS local lambda list-functions, and we get a error 400. So I'm going to ignore that. If you went back to this AWS help, one of them is CloudWatch, and there's also, I wonder what the difference between CloudWatch and logs is. AWS local CloudWatch help. Amazon CloudWatch monitors this, delete alarms. Let's see, is there like describe alarms? So this looks like it's interacting with CloudWatch. There's also a logs, which still uses CloudWatch, but it's a little bit different, I think. Yeah. So I'm guessing logs is how to like view native logs, and then the CloudWatch command would be viewing events. The difference between like a log and an event would be a log is a password denied, an event would be, oh, this was password denied 50 times. It's probably a brute force. It's my assumption, but we're going to do AWS logs. And then if we do describe log groups, we can see there is a CloudTrail log. So we can do, did I say CloudTrail? No, that was CloudWatch. I don't know exactly. But describe log groups. And if we kept doing help, we can find out there's a describe log streams, which is kind of like a folder. So when we do this, we have to give it a name. So log group name, I'm going to do CloudTrail. So it's going to list all the logs related to CloudTrail. And there's only one file, which is a stream. Streams are kind of like files. You can see each stream is going to be the date. So in 2020, 12/22, which is probably when this box was created, a good way to look at when a box is created, I like doing ls, la, etc, ssh, and then what is it? Yeah, ssh, and then grepping for key. So we can see, actually May 7th, 2020 is probably when this box was built. So built back in May, but this log was created in December. The reason why I use this for identifying like when a box was built is because people generally don't update the SSH host keys, because when you do, you get that nasty SSH banner saying the host key has changed. So this file generally gets created on boot and it stays the same. So maybe this is when like the container was made for CloudTrail, but we want to look at that log stream. So I'm going to, instead of do describe log streams, I'm going to say get log streams. And then we got to specify log stream name, and we can just copy this. AWS logs get log dash stream. Oh, get log events. We need the events in that stream. And we can see a bunch of things. So ingestion time and timestamp. This is the time the log was created. This is when it got ingested into the platform. I'm not sure why there's such a big delta here, but we can see rotate secret tag source, assume role, put scaling policy, rotate secret, rotate secret. If we look at the get T, there is something for key management, but this is KMS. So that's slightly different than what this is. If we do rotate secret, oh, come on, don't do Google. There we go. We can look at functionality around here, which is just part of the AWS SecretsManager. If I do AWS local help, and we search this for secrets, is it capital S? There should be a secrets manager here. I'm not sure why search wasn't working. LMNOP. Yeah, secrets manager. So we can do AWS local, secrets manager, then help, and see the functionality in here. Bunch of things, but the key one is probably list. Is there a list? Yeah, list-secrets. And we can see there are Jira support, sync panel, and Jenkins login. So we want to do a get-secret. Is it get secret or get secret value? I always forget this one. Help. It is, whoops. Come on. Get secret value. So get secret value. And if you did help again, you'd see how to use this. We want --secret-id. So we can do secret ID. And then what was the first one? Is it Jenkins login? And we can see username john@sync.hdb, and we have a password. So I'm going to cat etc passwd. Let's grep for ASH. And we have users root, Marcus, David, and Git. No user called John. Right? Yeah, so let's go back to the list secrets. The other one was sync panel. So let's look at sync panel. This user is Albert. We can look at the other one, Jira support. And this is David. And David did exist on the box. If I just grep David for etc passwd, we have it. And if we try this password, I'm not going to do the backslashes because backslashes are just escaping the double quotes. So su-David, paste the password in, and we are logged in as David. Doing an lsla on his directory, there is this projects folder. Going into it, there's prod deployment. And then we have this servers.enc file. Generally, enc stands for encrypted, but we can just run the ent command for entropy, and it's not found. So let's base64 encode it, -w0, so we put it all on one line. We can copy this to our host. So echo-n, paste this, base64-d. We can see it's a bunch of gibberish. Let's put it to blob.enc. Forget what it was called. But here I have this entropy command, and we can see it's 7.6 bits per byte. There's 8 bits in a byte. So this is high entropy. If we just look at standard text, like let's look at etc passwd, I'm going to guess it's between like 5 and 6. Maybe it's 4. Yeah, here we go. 4.8. So standard text is going to be around 4 to 6 bits per byte probably. But because this is so close to 8, chances are this is definitely encrypted text. We could xxd it to see if there's some type of header. So xxd servers.enc, and I don't recognize anything here. I was looking for like some type of algorithm beginning with it, but can't make sense of that. There was a KMS repository, which is a key management system, I think. And it talks about it, I think, like list keys and things like that. We don't have to use this app. Again, we can use AWS Local. And if I do KMS help, we can see the functions here. We can encrypt, decrypt files, things like that. But the main thing I want to do right now is list keys. So I'm just going to do KMS, list-keys, and we have a lot of keys. Unlike the like logs, we only had one folder. Going through each of these manually would be a pain. So I'm going to grep this for key ID. And then I'm going to say awk field separator is a double quote. And this would be 1, 2, 3, I believe. So I'll do print 3. And we get a colon. So this is probably 1, 2, 3, and 4. So it's probably actually 4. So now we just have a list of key IDs. So I can do for I in this, and then echo I, and we get a, I forgot to do echo I. Now we have a clean list of just key IDs. So from here, I can do AWS local. Then what is it? KMS, is it get key -- ID I, like that. So if I look at this, that's not it. List keys. Let's see, what is it? Oh, describe key, right here. So instead of get key, I'm going to do describe key. And we need -- key - ID. Like that. And we output a bunch of information about this. Like we can see its usage, what type of state it's in. It's disabled. So this is probably why that well, no, I was going to say why the key was rotating, but that was a different key management system. But we probably should look through each of these keys and find out which one is disabled. But first, let's fix this. So KMS, and it is describe key. And this is -- key ID. And once I get this command working, I'm going to clean up the syntax and just put it in a bash script for like readability. Okay, so we have this. So what I want to do is grep for key state. Let's see. We got to get rid of this echo because it's just echoing the command. So I actually want to run AWS local now. And we're getting a list of all the key states. So we can see disabled, 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 enabled. And the issue we're having right now is we don't know what the key ID was anymore. So let's go back to our loop. Before we do this describe key, I'm going to say echo -n. And then we can say I semicolon, or colon, and then end it with semicolon. And now we can get a list of every key. So let's go and clean this loop up in case you wanted to read it and have trouble with this line break. So I'm just going to do it in a new thing, get keys.sh. So this is the for loop. Put a line break after do, echo like this. And that's the loop. So for every key up here, echo the key name, then run this AWS local command. So now we just want to describe these two keys. So we can go all the way up here, put this key ID, and look at the purpose of this key. We can see encryption and decryption, so that looks good. Let's just, for sanity check, this second one, see if this is also for encryption. We can see this is digital signature verification, so we don't really care about that. We just want this key. So we have an encryption decryption key. If we do AWS local KMS help decrypt, so let's do decrypt help. We can see how to use this decryption. So here's all the arguments. We definitely want the ciphertext and the key ID. And then encryption algorithm. So let's look at the encryption algorithm a little bit. Encryption algorithm, and there's 3 possible values: symmetric, RSA, AES, OEP, SHA-1, and SHA-256. I'm just going to put, actually, let's copy this. I was going to put one on my clipboard, but I'm probably going to use my clipboard for other things. So, let's see. There we go. V keys. So we have that saved. Okay, this is definitely the key, right? Encrypt, decrypt. So instead of describe key, we're going to change this to be decrypt. And then we want to do the key ID, which we have there, and then ciphertext blob. And we can say file, and I think it's just servers.enc is what it was. And then encryption algorithm, and we can say symmetric default. And then output is equal to text. Ciphertext blob, unable to load parameter. Please use file B instead of file. Okay. Not exactly sure why. Maybe it's like file blob, but hey, whatever it tells me to do, I'm going to do it. So invalid ciphertext exception when calling. Don't know what that is. I'm just going to change to a different algorithm. So the next one was RSAES underscore OAEP SHA-1. And let's try SHA-256. And we actually get data back. It's a base64 bit, or blob, but we have data. So let's echo-n. It looks like I copied the line break. Let's leave it this. Copy up to here. Echo-n, base64-d. And I don't know exactly what we have here. Oh wait, it outputted to text. Right? So we did servers. Let's see, output text. I was thinking maybe that was a text file. Let's just try copying this again, and we'll do it on our box. And we're going to check the entropy. So echo-n, the base64. I'm just call it unknown. Like that. And then ENT unknown. 7.2 bits of entropy. If we run file against it, it says it's gzip data. If I had xxd'd it, I think this is the gzip magic byte. All these, like this 8 O's in sequence, this indicates that it's not random data. So the chance of having all these years in a row would be low. So since file told us it was a gzip, let's just rename this. So I'm just going to move unknown to unknown.gz. And we can say gzip-d unknown. And now if I do file against unknown, it's just a tar archive. So we can do tar-xvf unknown, and we get 2 files out of that. So this was a tar.gz. If we make dir, oh, we already have temp. I'm going to move unknown.gz. Actually, it's removed. Echo. So move unknown to temp unknown.tar.gz. So you could have done it this way if you knew it was a tar to begin with. And just did tar-xjvf, I think, for gzip. Let's see. xzvf, unknown tar.gz, and also extract the files that way. So we have servers.sig and servers.yaml. And we have admin, and then what looks like to be a password. So we can, again, try this password on the box. So su dash, paste in this password, and we are now root on sync. So we can cat root.text, and we have the key. But before we end the video, I wanted to show off one super cool technology that went into this box to make it stable. When Mr. Reboot created this box, it was originally not friendly to multiple users doing it because that HTTP smuggling piece. That's a very big race condition that depends on the next person making an HTTP request, and the first revision of this box only had one Docker container running, and in reality, we have 16 containers running, and we do some IP modular routing to send people to unique containers. And the reason why is if you were doing a GoBuster attack on this box while I was doing an HTTP smuggling, then the automated user would never tag onto my smuggling attack because GoBuster was always going to be the next HTTP request. So we needed to come up with a way to help minimize the chances of some other user getting onto your smuggling attack. So what we came up with was routing based upon the last octet of an IP address and sending that to a unique container. If you watched my last video, the UHC September qualifier, I went with a kernel module to do this. OXDF was looking at IP tables simultaneously because we knew it was possible in IP tables, but weren't quite sure on the syntax, and if we didn't do it in time, we would have defaulted to the kernel routing because I knew how to do it in the kernel. The reason why we didn't want to go with a other load balancing solution like Pound is because that would break the HTTP request smuggling altogether, because the Pound may behave differently than HA proxy, then that goes to gunicorn. We didn't want to put another technology on top of HA proxy. So that's why we were going with IP tables or kernel module. We went with IP tables because there's less custom code involved, which means there's a less chance of vulnerability, at least in our eyes. I don't trust the code I write. I threw it in the UHC box because I wanted to see it work, but could have used this IP tables method. So if I do IP tables-L-N, I'm actually not going to see the routing because it's on the pre-routing chain. So we have to do -t-nat to show those chains. And whenever you're looking at IP tables, you should throw this flag in because someone malicious may put something in this pre-routing thing to change where things go. Yeah, there it is. So we can see these are the rules. If you don't want to remember that, you can just do IP tables-save, and I actually prefer this output more. So we can see here's all the IP tables rules we did to make this. So this is -s for source. So this is looking at the source IP, and then it does some weird subnet mask thing. So IP tables does everything inverted, and I think this was the big key OXDF found out to make this rule work. In traditional subnetting, this would be 255, 255, 255, 240. And this last octet is 15. 240 plus 15 would be 255, which means that subnet mask bit is full, which is key for subnetting. But there's going to be a total of 16 IP addresses in this block because 0 is not null, it's an actual value number. So 0 to 15 is equal to 16. So that's why we have 0 through 15 here. This is just saying if it's TCP, this is destination port 5000, so only if it's going to that gunicorn server, and then -j dnat, this is routing it to the actual container. So this is the first container listening on 6000, but it's going to 8080, second container, third container, fourth container, whatever. So 10.10.14.0 matches this. 10.10.14.1, 10.10.14.2, 10.10.14.3, ... 10.10.14.15 goes here. And then how subnet masks work, if we did 10.10.14.16, it goes back down to 0. This would be 17, 18, 19, and then this would be, I think, 31 would match here, and 32 would go back up here. So that's kind of how the IP tables modulo routing thing works. So hope that made sense. Take care, guys, and I'll see you all next week. Oh, if it doesn't make sense, view OXDF's blog. I'm sure he does a much better explanation of it. But yep, take care, and I'll see you all next week.